Hi everyone, in this video we continue our investigation of transformations of functions. So in the example below we're told, given the graph of y is equal to f of x to the right, determine f of negative 7 plus 3, f of negative 5 plus 3, f of negative 3 plus 3, and f of negative 1 plus 3. So if we evaluate f of negative 7 plus 3, well that's the same as f of minus 4. So f of negative 4 is positive 4. So f of negative 7 plus 3 is positive 4. F of negative 5 plus 3, well, that's equal to f of negative 2. And f of negative 2 is 0 from our graph. F of negative 3 plus 3 is equal to f of 0. And f of 0 is positive 3. F of negative 1 plus 3, well, that's equal to f of 2. And f of 2 is equal to positive 1 from our graph. So below we're also told to plot the graph of y is equal to f of x plus 3. So let's think about this. Okay, well, I know that if I plug in an x value in for, or when x is equal to negative 7, f of x plus 3 is going to be 4. So when x is equal to, let's plot that point. Well, when x is negative 7, f of x plus 3 is positive 4. So let's count back. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Okay, and now let's think about what point this corresponds to. Well, okay, what happens when I add 3 inside the brackets? What's going to happen to the function f of x? Well, here what happened with this point is I end up getting the value for f of negative, or for f of negative 4 3 units earlier. Okay, so this can be thought of as a horizontal translation 3 units to the left. So this point gets translated 3 units to the left. It's a horizontal translation 3 units to the left, because I end up getting the value of f of negative 4 only because I'm adding 3. I get the value for f of negative 4 3 units earlier on my Cartesian grid, or on the Cartesian plane. And it's the same thing with this next point, f of negative 2. Well, I get f of negative 2 now at negative 5, when x is negative 5. So this point gets translated 3 units to the left as well. So the first part of my graph looks like this. Now let's think about what happens with this point. Well, I get f of 0 when x is negative 3. So f of 0 is positive 3, but I now get it when x is negative 3. So this point gets translated 3 units to the left as well. The same thing for f of 2. I now get f of 2 when x is minus 1. So this point gets translated again 3 units to the left. And you can probably guess that this point as well, I'm going to get f of 4. I'm going to get f of 4 3 units earlier. So this is another translation 3 units to the left. So you can see that when k is positive, or when I have f of x plus 3, this is a horizontal translation 3 units to the left. So this graph that I've just produced is f of x plus 3. This shifts my graph 3 units to the left, because when I add 3 inside of the brackets, I get each of the corresponding values of f of x 3 units earlier on the Cartesian grid, or on the Cartesian plane. Next, let's evaluate these values. Well, okay, I'm evaluating f of 7 minus 3. F of 7 minus 3 is equal to f of 4. And f of 4 is negative 2. f of 5 minus 3 is equal to f of 2. And f of 2 is 1 from the grid. F of 3 minus 3, well, that's equal to f of 0. And f of 0 is 3. And f of 1 minus 3, well, that's equal to f of minus 2, which is equal to f of negative 2 is 0. Okay, now let's do the next part of this, and let's plot the graph of y is equal to f of x minus 3. So how do we plot the graph of f of x minus 3? Well, let's think about when x is 7. When x is 7, I get f of 4. Okay? So when x is 7, I get f of 4. Let's plot that on my grid. So when x is 7, I get f of 4, which is negative 2. So again, let's count 1, 2, 3, 4, 5, 6, 7. And when x is 7, I get negative f of 4, which is negative 2. When x is 5, I get f of 2. So f of 2 was 1. But now I get that when x is equal to 5. So 1, 2, 3, 4, 5. So I get a point here. So notice what's happened for this segment of my graph. I have a shift of 3 units to the right. So if you want to graph f of x minus 3, if we continue this trend, you'll see that all of these points get shifted 3 units to the right. So if I want to figure out where this point gets, is on the graph of f of x minus 3, I can just look at the graph of f of x and shift this point 3 units to the right. Same thing for this point. This unit this coordinate shifts 3 units to the right. And this point shifts 3 units to the right as well. So this is the graph of f of x minus 3. F of x minus 3 shifts the graph 3 units to the right because think about f of 1 minus 3. You'll get the corresponding value for f of x 3 units later now. 3 units later on the Cartesian plane. So that's why we f of x minus 3 shifts the graph of f of x to the right 3 units. So how is the graph of f of x, y is equal to f of x plus k, related to the graph of y is equal to f of x? Well, we've got a couple, two different cases. When we're subtracting a positive value inside of the bracket, that's a shift to the right. When we add a value inside of the brackets that's positive, that shifts the graph to the left. So if k is greater than 0, let's say let's write that in a mathematical form. If k is greater than 0, then f of x plus k is a shift k units to the left. If k is less than 0, then f of x plus k is a shift absolute value of k units to the right. So when you have, like, let's say I were to have f of x minus 5, well, f of x minus 5 shifts the graph of f of x 5 units to the right. If I had f of x plus 11, well, f of x plus 11, this would be, the graph of this would be the graph of f of x shifted 11 units to the left. So if I know what my function f of x looks like, I can I've got it written in the form where I have f of x plus k. I know how to graph f of x. I know how to produce the graph of f of x plus k, because it's either a shift to the right or it's a shift to the left, depending on whether k is positive or negative.